can be modeled by the relation h equals negative 0.1 d squared plus 0.5 d plus 0.6, where h is the ball's height and d is the horizontal distance from the kicker, both measured in meters. Find the zeros of the relation. Because they're asking you for the zeros of the relation, what does that mean? What form do you need it to be in? See? Now, for next question, you're going to ask me that question. I'm not going to ask anymore. All right, so factored form. What's the process of factoring? You first ask yourself what? Greatest common factor. Do I have a greatest common factor? Yes. What is it? Negative 0.1. Right? So remember that if it's negative, you're going to have to divide by negative. And then I told you that most likely, if there is an a value, that's going to be it. So you're dividing by negative 0.1 for all of them, right? So that's going to be negative 0.1. And then d squared, stop me if you don't understand. 0.5 divided by negative 0.1 is negative 5d. And then negative 6. Perfect. So now you see that my leftover is a trinomial. Trinomial means I have to follow what process? Sum and product. So I'm looking for two numbers that multiply to what and add to what?
Multiply to negative 6 and add to negative 5.
So what multiplies, since both of them are negative, that means my large number has to be negative and the small number has to be positive. So what multiplies to negative 6?
Plus 1, negative 6.
1 and negative 6. You already found it, right? Because that adds to negative 5. Right? So that's going to be negative 0.1. You're going to have two brackets. It's going to be d plus 1 and d minus 6. Anyone doesn't know how to get to this point? Now it's in factored form, yeah? How can you find the zeros? Set each bracket equal to 0. So d plus 1 equals 0. That means your distance is negative 1. And then d minus 6 equals 0. So that means your distance is 6. So here it is. I'm kicking a ball. The ball is at distance of negative 1. Where am I? Where am I standing? With respect to the x and the y axis. Where am I standing? On the y axis. So this is the y axis and this is me. Right? I'm kicking the ball, but the ball is at negative 1. So where is the ball right now? 6. Behind me. The ball is behind me. Does that make sense to you? Can I kick the ball when the ball is behind me?
No.
I don't think so.
All foolishness
I
aside.
barely can kick the ball if it's in front of me. Right? So in this case, I'm going to have to omit some of my answers because that answer does not make sense. Right? So instead of actually having the ball at negative 1, which is behind me, and then dropping it 6 meters away from me, right? I actually probably have kicked the ball from the air. Either by like, I don't know, doing a headshot or turning in the air and then kicking it. I can't do any of this, by the way, right? But it's probably, right, the ball is not behind me because I can't kick it from behind me. It wasn't on the ground. It was somewhere in the air, okay? So in this case, I have to omit this part, right? So when is the ball touching the ground? 6 meters away from the kick, right? So sometimes you have to be careful with your answers, okay? So let's write that down. What is it? Why would it become 5 meters? Nope. That's 6 meters away from the 0, right? So it is still 6 meters away from the 0. So we're gonna say the negative 0 is discarded. I'm just gonna add d negative 1. Since distance cannot be negative, and d equals 6 is when the ball hit the ground or land on the ground. Should say where, not when, because it's a location. Okay, so you're gonna imagine this, that you are hitting the ball from the air, right? The ball is gonna go up and then it's gonna land 6 meters away from you. Does that make sense? Can you picture that? Do you play soccer?
Yeah.
You used to? No. Played volleyball. When I was little. Can't play it anymore because I don't want to win this.
Oh, your nails.
And I don't want to hurt myself. All right. Do we understand this? All right. Here's your next question. The arc of a small suspension bridge over a river can be modeled by the equation y equal negative 2x squared plus 4x plus 6, where x is the distance in meters from the edge of the river and y is the height above the ground, also in meters. So what do we have here? Standard
That's
form. Okay. What do we have? What scenario do we have here? What scenario do we have? We've got a bridge. What else?
Edge of the bridge.
We have edge of a river, right? So we have the river, right? So the river is going to act as your what in this case? As your y-axis, right? So your river is, the edge of the river is your y-axis, right? And then, how are you going to draw the bridge? How would you draw the bridge? On both sides of the river, or just on one side?
One side.
Why do you need a river then? Why do you need a bridge? Sorry.
Only like the edge of the river, but there's like the other side of it.
Yeah, but the whole reason they built the bridge is to cross the river, no?
Yeah.
Right? The whole reason they needed a bridge is because they need to be able to go from one side of the river to the other side.
Oh, so we need to, yeah. We
Not
only get
just
the
the
edge.
of the river, it's the whole river.
Well, there is a river, right? But they're measuring the distance from the edge of it. Okay? So this is the edge of the river, and they build a bridge on top of it, right? Because they need to be able to cross that river, no? Right? So in this case, the bridge is going from either sides of the river, right? So when I'm graphing it like this. So the river is gonna start on one side, so the bridge is gonna start on one side, it's gonna go up, and then it's gonna land somewhere on the other side. So the people can go and cross it, right? Yes? Does that make sense?
Where's
Yeah.
the edge?
This is the edge.
Okay.
Okay? So if I'm going to build something here, right? If this is the edge of the river, right? And I want a bridge on top of it, so I'll do this. Look. Right? Can you see that? So this is my river. This is the edge of the river. The river is pretty wide, but we're measuring from one edge. Okay? This is the edge that we're Can I take out part of the river and just have it like suspended, just like this, from here to here? Can I do that? No, because then people are gonna, where are they gonna go?
Right into the river.
Yeah, right? So you have to be careful here. There's some things that you can't omit. All right, what are the zeros and what do they represent?
The start of the bridge?
More like the middle.
What are the zeros?
Yeah. Yes, these two boards.
Come and point at them, please.
There.
Yes. So the zeros are right here. Thank you. So the zeros are right here. So what are you asking me right now?
What is
Number. This what letters?
Yes, Alina.
The start of the bridge and the end of the bridge.
Okay. So what do you want to ask yourself right now? Yes. Yes, Deanna. What form do you need to put it in? Okay. So what form do you need to put it in? Factored. Okay. How do you factor this? How do you factor this? Quickly. Yeah.
divide them and find the GCF?
Find the GCF. What's your GCF? -2. Guys, remember that if your A value is negative, you have to factor out a negative, right? So dividing by -2. So what does that give you?
X squared negative x squared and
Minus
negative
2x
negative 3.
minus 3. Okay, so I factored a GCF. My leftover is a trinomial. Trinomial means what? Sum and product. So I'm looking for two numbers that multiply 2,
-3,
add 2.
-2.
So what multiplies to -3? Again, both of them are negative, which means the large number has to be negative and the small number has to be positive. -3 and 1? Yeah? I don't have too many options here, do I?
So that's it.
What are the zeros?
3 and -1.
3 and -1.
Stop getting it wrong.
Okay, guys. 3 and -1. What does that mean in this case? So it's going to begin at -1, so 1 meter away to the left of the river, right? And 3 meters to the right of the river, right? In this case, can I omit part of it? No, because otherwise I'm going to be suspended in the air, right? And I don't want that. You don't want that, trust me. Yes.
How do you know which one is which?
Because usually the left is the negative and the right is the positive. Right?
And it's like in the,
Right? And the river is in between. Remember that we chose the river to be our y-axis. Right?
we chose it.
Yes, because that's what they told us, actually. It's measured,
Oh,
it's measured from the edge of the river.
okay.
Does this picture make sense to you? Okay. Now, how long is the bridge? Horizontally.
4 meters long.
4 meters long, right? The bridge starts here and ends here, right? So my whole bridge is horizontally 4 meters long. How do we know that?
It started at 1, so it's
Can someone explain how do we know that?
Yeah, but it started at -1. It didn't start at 1. So you gotta, from -1 to 0 is another one, right?
So from -1 to 0, that's 1 meter, right? And then, so this is 1 meter here. And then from here to here, that's 3. 3 and 1, that's 4. Right? It's a total distance. Remember, negative means nothing negative, actually. All what it means is to the left of the river or to the right of the river. That's all what it means. you're gonna have to kind of take your numbers and take your ideas and, how do you say that? Like, think about them logically, right? Don't think about the numbers as just minuses and plus. Think about what do they mean in my real scenario, in actual life, right? Sometimes it means that it's behind you and you can't even consider it, but sometimes it means you have the river and you have the left and the right of it, right? You have to consider both. It will make sense if you actually do more practice. Honestly, they make sense. Like, to me at least, I don't know. Me? How long have I been teaching that? 2014? 2014? 20, no, I was a baby then. I mean,
Wait.
no, 2014 I started. But I started with science.
Science.
Science my first year.
So this is like this is nothing to you then.
What?
This math. You started teaching science.
Okay.
I prepared it for myself. Let me tell you that. All right.
Science is hard. Yeah. Chemistry.
That's my first degree.
Your first degree is chemistry?
Okay.
Chemistry is
I think I know it. Probably wrong.
All right.
That's some like Einstein. That's some good stuff. Physics is on some.
All right, guys, let's get back to this question, please. Remember, recording, we can waste time. All right. Now, rider on a mountain bike jump off a ledge. Her path is modeled by the relation y equals negative 0.3 d squared plus 1.2 d plus 1.5, where h is her height above the ground and d is her horizontal distance from the ledge, both in meter. What is the height of the ledge? Just 1 second. So describe that scenario for me. What's going on?
She's about to jump off a cliff.
Okay, come here. This is she. Where's her ledge? Explain to me and what's going to happen to that she.
Wait, okay, this is the ledge,
Okay,
and she's about to jump off.
okay, and how is she going to jump, do you think? Yeah. Okay, do it. Let it go. No, you have to let it go a little bit higher. Try again. All right. Yes. All right. Now, where is she starting at?
Mid-air,
Where is she right now?
on the ground.
On the left. Where's the ground? The ground is where you're standing. Is she on the ground?
No, she's on the ledge.
She's on the ledge. So the question is, what's the height of the ledge? How do you determine that? How do you determine the height of the ledge? That's C. That's the initial point. That's where she's starting from. Right now, she's starting right here. She's starting at the ledge. That's where she's starting. She hasn't moved yet, right? She's standing at the ledge, and the height of the ledge is C. Right? Now, land her on the ground. Okay, landed on the ground. How far was the rider from the ledge when she landed? What am I looking at?
Literally just, it doesn't matter if it's more below, it's just the same.
So what point am I looking at?
Both of the axes.
Not B, but what is it? D.
D.
What's D?
The y integer.
When she lands on the ground, what does that represent?
The zero.
The zero.
The zeros. Thank you.
That's what I just said.
You said D.
No, at
said
first I
D.
said the zeros.
Sorry, I did not hear that. All right. Thank you. So what's the height of the ledge? We know that we're looking for the initial height, right? Because she's standing there. She's not moving yet, right? She hasn't jumped yet. And I can find the initial height using the standard form. It's already in standard form. I don't have to do any work. It's right there for me. Right? Now, because they're asking me how far was the rider from the ledge when she landed, I'm looking at the x-intercept, sorry. So this is what's happening. That's the ledge. She's jumping up, and then she's gonna land somewhere away from the ledge, right? I wanna know where she lands. What form am I looking at? Factored. I hope it's factored because we're looking at when we land on the ground, right? That's the x-intercept. All right, so y equals what? D squared plus 1.2 d plus 1.2. All right. What are you thinking? Greatest common factor. Good. What's my greatest common factor? So if I divide everything by negative 0.3, what do I get? Yeah? Minus 4d. I have to put it in factor. That's what I'm working toward, right? So I did the GCF first. And now I'm doing something else. Okay, what's that? Sorry, what's
Minus 5.
okay? Binomial, trinomial. Trinomial. Trinomial means sum and product. I'm looking for two numbers that multiply to negative 5, add negative 4. So that's going to be 1 and negative 5. Don't have too many options, right? So that's going to be negative 0.3 d plus 1 d minus 5. So what are your zeros? 5 and negative 1. So d equals negative 1 and d equals so in this scenario, what's happening here? Yep. Okay, so you see that d is negative 1, right? This part, we're not going to take that into consideration because that's behind her. She's standing already at the ledge, right? So we're not considering that. Where is she going to land? 5 meters away from the ledge.